Bright Tuty. Every student matters.
Let me demonstrate this question to you. This is a particular category of question. So you will be able to solve this category of questions after doing this question. So what is tan of A? It is 4 by 3. And find the other trigonometric ratios of angle A. So first of all, make a right angle triangle here. A, B, C, right? Always keep in mind that mnemonic I taught you. So, ka, toa. What is tan? It is opposite upon adjacent. So, what is opposite of A? This is opposite of A. This is opposite only for angle A, right? If we are talking about angle C, then this side will be opposite. But for now, we are talking about angle A. So, this is opposite. So, this is adjacent. And this one is the hypotenuse, right? So, let us write it. I am just writing these to demonstrate you. Otherwise, it is not necessary to write these things. Okay, you can do it directly. What is tan of A? Tan of A is 4 by 3. So, the ratio of opposite side and adjacent side is 4 by 3. What is opposite side? Opposite in this case is BC, adjacent is AB. So, this ratio is given as 4 by 3, right students? So, this is the ratio that is given, right? So, it is not given the question has not given the absolute value of side BC. So, if some student says that the side BC is 4 units, no, he is wrong, because even if this side BC is, let us say 12 and side AB is 9, the ratio will still be 4 by 3, right? So, you always take these sides as 4k, 3k, and k can be any integer, right? So, in this particular case, tan A is equal to 4 by 3, and what is tan A? It is BC upon AB. It is equal to 4 by 3, right? So, let us assume BC equal to 4k and AB equal to 3k. I have explained you the logic here, right? So, let us take this BC as 4k and this AB as 3k. Now, the job is very simple. We need to find other trigonometric ratios for angle A. So, what is sine of A? It is so, opposite upon hypotenuse. So, opposite side is 4k, but hypotenuse is still not available, right? So, how can you find the hypotenuse? This is a right angle triangle, so you can just apply the Pythagoras theorem. So, by applying Pythagoras theorem, we can say AC squared is equal to AB square plus BC square. What is AB square? 3k whole square. And what is BC square? 4k whole square. So, this will give me 9k square and 16k square. So, AC square is equal to 25k square, hence AC is equal to 5k, right? So, this side is 5k, okay? And students, these are Pythagorean triplets that you should already know. You do not have to calculate these things. You should know the Pythagorean triplets. For example, 3, 4, 5 is a Pythagorean triplet, because if you square 3 and 4 and add them, you will get square of 5. 3 square is 9, 4 square is 16, sum is 25, which is 5 square, right? So, such triplets are known as Pythagorean triplets, which satisfy the Pythagoras theorem. So, once you see that 3k and 4k are there, the third side will obviously be 5k, and I have proved it here also. So, what is sine of A? Sine is opposite by hypotenuse. What is opposite? 4k. What is hypotenuse? 5k. So, what is sine of A? 4 by 5, right? So, what is cos of A? Ka. adjacent upon hypotenuse. Adjacent is 3k and hypotenuse is 5k, so it will be 3 by 5, right? And it is sufficient to calculate these three. Sine is calculated, cos is calculated, tan is already given. Tan of A was what? 4 by 3, right? So the rest of the ratios we can write like this: cosecant, cot, secant. What is cosecant? Cosecant is reciprocal of sine. So just the reciprocal of 4 by 5, which is 5 by 4, right? What is reciprocal of tan? It is cot, right? So cot will be 3 by 4. What is secant? It is reciprocal of cos, so it will be 5 by 3. So we have got all these ratios, right? So these category of questions are to be done like this. You assume these sides using this SOHCAHTOA rule and then go about the ratios. Okay students, let's talk about this question now. If angle B and angle Q are acute angles such that sine of B is equal to sine of Q, then prove that angle B is equal to angle Q. We spoke about this in the introduction part also, right? That let us take these two triangles, triangle ABC and triangle PQR. Angle B and angle Q are acute angles here, and it is given that sine of B, what is sine of B? You need to keep this in mind, SOHCAHTOA, right? Sine is opposite by hypotenuse. So sine of B is opposite by hypotenuse. And what is sine of Q? It is opposite PR by hypotenuse QP or PQ, right? So effectively it is given that the ratio AC upon AB is equal to ratio PR upon PQ or QP, whatever you take, right? So if I can write this ratio like this, just to simplify it, AC upon PR is equal to AB upon PQ. I have done nothing here. I have taken this AB on this side here and PQ, AB here and PR here, right? So this expression is same expression as this one. So this ratio is equal. Now let me talk about the third side. We have covered in this ratio AC and AB. So side BC is left. Let's talk about BC first. Okay. So it is given that AC upon AB is equal to PR upon PQ. I can take this ratio as equal to K, right? So when I talk about BC, what is side? I can apply Pythagoras theorem here. So what is BC square? It is equal to AB square minus AC square, right? And what is the relation between AB and AC? What is the relation between AB and AC? AC is equal to AB into K, right? So AB square minus AB square into K square, right? So what I can do here is I can write it as AB square 1 minus K square. So BC square, BC upon AB is equal to root of 1 minus K square, right? I have brought this AB square on the left hand side and taken the square root on both sides. Similarly, if I talk about this third side here, QR, what I can say is QR square is equal to PQ square minus PR square, and from this ratio here, PR is nothing but K into PQ, right? So PQ square minus, this is K into PQ, so I can write it as PQ square into K square. So I can take PQ square common, 1 minus K square. So what is QR upon PQ? It is root of 1 minus k square. So I can say that BC upon AB is equal to QR upon PQ. Okay. So now you can see that this ratio BC upon AB is equal to QR upon PQ. Okay. So I can write here is in triangle ABC and PQR, AB upon PQ is equal to BC upon QR, right? From here you can take this QR here, so it will become BC upon QR, which is equal to AB upon PQ, hence this result, right? So AB upon PQ is equal to BC upon QR, which is equal to AC upon PR. So what can you say about these two triangles now? That these two triangles are similar because ratio of all three corresponding sides is equal. Hence I can say triangle ABC is similar to triangle PQR, and hence corresponding angles of these two triangles are equal. So angle B will obviously be equal to angle Q, right? So this is the way we will prove that angle B is equal to angle Q, right? Okay. So let's move to the third category of questions here. Let's consider this triangle ABC right angled at C. Let's make a triangle. First of all, let's make this right angle here, and this is C, right? Where AB is 29 units and BC is 21 units. Let's take this as B and this is A. BC is given as 21 units, AB is given as 29 units, right? And angle ABC, so this is angle ABC, right? This has to be named as theta. So this is the given information in the question. Now we need to determine the values of these expressions. Okay. So first of all, let's determine this third side here, right? Because for the ratios, trigonometric ratios, we will require this third side also. So what will be side AC? AC square will be equal to AB square minus BC square by applying Pythagoras theorem. Okay. So what is AB square? It is 29 square. What is BC square? 21 square, right? So now for the calculation purpose, how many of you know that 29 square is what? What you can do here is you can write it as 29 plus 21 into 29 minus 21, right? To simplify the calculation. A square minus B square can be written as A plus B into A minus B. So what is A plus B here? It is 50, right? And what is A minus B? It is equal to 8, and so the product is 400, right? So 29 square minus 21 square is 20 square, which is 400, right? So AC square is 20 square, so AC is equal to 20, hence we can say that this side is 20 units. Now again that mnemonic will come into the picture, so ka toa, right? For cos, what is cos theta? Adjacent upon hypotenuse. What is adjacent side here? 21. What is hypotenuse? 29, right? For sin theta, we can write, so opposite upon hypotenuse. What is opposite here? 20. What is hypotenuse? It is 29, right? And I need the squares here, so I can square these. Sin square theta, cos square theta. This will be 21 square, 29 square, 20 square, 29 square, right? So I need to add these now. Let's add these. Sin square theta plus cos square theta is equal to 21 square by 29 square plus 20 square by 29 square. This is sine square theta, this is cos square theta, right? Now you can add these. 21 square is 441, right? What is 20 square? It is 400. What is 29 square? You should memorize the squares up to 50 at least, right? Otherwise you can calculate it there and there itself. If you memorize these squares, it will save a lot of your time. So 29 square is nothing but 841, right? So this is equal to 841 upon 841, hence this will get cancelled. So the answer is 1. Okay. So for this expression, this is equal to 1. In the upcoming lectures, we will learn that you can directly answer these questions. Sin square theta plus cos square theta is always equal to 1, right? Okay. What is cos square theta minus sin square theta? So we have already calculated cos square theta and sin square theta. So what is cos square theta? 21 square by 29 square. And what is sin square theta? It is 20 square by 29 squared, right? So what is LCM? 29 square, and how much is 29 square? It is 841. What is 21 square minus 20 square? It is equal to 41, right? 441 minus 400, it is equal to 41. So it is 41 upon 841. So this is your answer for the second part. This calculation also is very simple. 21 square minus 20 square can always be written as 21 plus 20, 21 minus 20. This is 1, so this is 41, right? So 41 by 841 is your answer. Okay, let's do one more question here. In a right angle triangle ABC, right angled at B, so this has to be named as B. Let's name this as A and this is C. Tan A, we are talking about this angle here. Tan A is given as 1. What is tan? You need to memorize this, TOA, opposite by adjacent. So what is side opposite to A? It is BC. What is side adjacent to A? It is AB. So BC upon AB is equal to 1. Hence we can say BC is equal to AB, right? So we have got one result from here. Now we need to verify that 2 sin A into cos A is equal to 1. This is to be verified, right? So to verify this, we will require sin of A and cos of A, okay? And it is given BC is equal to AB, right? So if I take BC as K, I'll have to take AB as K, right? So what will be side AC? AC will be K square plus K square square root. Why? By applying Pythagoras theorem. So this is 2K square square root, which will be root 2 of K. Hence you can write it as root 2K, right? So what is sine of A? Let's do it here also, here itself. What is left hand side here? 2 sin A cos A. So 2 into, what is sin A? Opposite by hypotenuse. What is opposite? K by hypotenuse. What is hypotenuse? Root 2K. Okay. What is cos A? Adjacent upon hypotenuse. What is adjacent side? K. Hypotenuse again root 2K. Right. So what is the left hand side here? This K gets cancelled. This K gets cancelled. 2 upon, this is root 2 into root 2, which will give you 2. So 2 gets cancelled here. Left hand side is equal to right hand side. So the result is verified. This result, 2 sin A cos A is equal to 1 for this particular triangle is verified, right? Okay. So for this lecture, let's leave it to these questions. In the next lecture, we will do a lot more questions and then we will do some extra question from the board point of view also. Okay. So thank you. So in triangle OPQ, right angled at P. So there is a triangle, right angle triangle here, and this right angle is named P, right? OP is equal to 7. Let's take this OPQ, and this OP is given as 7 centimeter. Okay, and there is another relation is given, OQ minus PQ, it is equal to 1 centimeter, right? And we need to find the values of sine of Q and cosine of Q. So we will be talking about this angle. This is angle Q, right? So we need to find sine and cosine of this angle. So for finding sine and cosine, we need these sides also, right? And we have got only one side here, but the question is giving some relationship. This relationship is to be used to find the other two sides, right? So this is one relationship. We need a second relation also, because there are two unknowns, so we need two equations. So we have got one equation here which is given. Second equation can be made by using Pythagoras theorem. So by using Pythagoras theorem, we can say OQ square is equal to OP square plus PQ square, right? This is the what the Pythagoras theorem says. Now OP square is already known, so we can say OQ square. OQ from this equation can be written as 1 plus PQ, right? From equation 1, I can say OQ is equal to 1 plus PQ. So let's use this one here in this equation. Okay, so I can write this OQ as 1 plus PQ, and now square it. It is equal to OP square plus PQ square, right? This OP square can be written as 7 squared, this PQ square as it is, and from left hand side let's open this bracket, 1 plus PQ square plus 2PQ, right? And this PQ gets cancelled. Okay, so you can see 1 plus 2 into PQ is equal to 7 squared, which is equal to 49, right? So 2 PQ is equal to 48 and PQ is equal to 24. So I have got this side also. This is 24 units, 24 centimeter, right? So now I need to find the third side, which is OQ. So what I can do is I can put it in this relation, right? OQ is nothing but 1 plus PQ. So PQ is 24, so OQ is 25. Otherwise you can apply Pythagoras theorem, 7 square plus 24 square, 7 square is 49, 24 square is 576. When you sum these, 625 square root 25, right? Third way that you need to memorize the Pythagorean triplets, 7, 24 and 25 is a Pythagorean triplet. Okay, anyways, we have found these three sides. Now finding these ratios is very simple. What is sine of Q? Opposite is 7 here by hypotenuse 25. What is cosine of Q? Adjacent, which is 24, upon hypotenuse, which is 25. So this was about this question here.